Hi everyone, welcome back to Nuskrit. So let's solve today's daily lead code challenge, which is subarray product less than k. So let's try to read the problem statement first. So we are given an array of integer nums and an integer k. We need to return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. So let's see one example. Here we are given a nums array which is 10, 5, 2, 6 and we are given a k value which is 100. Now we can see that the total number of subarrays which are having product less than 100 will be 10, 5, 2, 6, 10, 5, 5, 2, 2, 6 and 5 to 6, which is 18 numbers, right? So there are total 8 subarrays. Okay, you can see 10, 5, 2 cannot be the answer because the product of this subarray would be 10 into 5 into 2, which is equivalent to 100 and it's not lesser than 100, right? So the problem statement is very simple. There is one prerequisite for this problem. So if you will go to our website learn.nuskrit.in and you will go to blog, and if you scroll up a little bit, you will find this problem, binary subarrays with sum, right? So if you'll open this, you will see that we discussed 3 different approaches in this particular question, that is prefix sum, then sliding window unoptimized, and then finally sliding window optimized, right? So I would highly recommend that you go back and watch this video to literally get the taste of this particular approach, right? Great. But yeah, let's come back to the problem statement. Let's take one example and let's do it quickly. So here I have taken the same example. This is the num array 10, 5, 2, 6 and the indexes are like this, right? What we'll do is we will simply say, like we will simply take one start variable, okay? We will simply take one start and one end. So start will also start from 0, okay? And this end will also start from 0 index. Now what I will do, just try to look at this very carefully. What I'll do, I'll simply take one variable product in which I will be storing the product so far, and initially my product is actually 1, right? Now I will take this value initially, the first value, and I will multiply this value with my product, hence the product will become 10. I will check if my product is greater than 100 because here the k value is actually 100, right? So my product is not greater than 100 or equal to, like greater than equal to 100. So what I will do, I will take this subarray, like I will count the total number of subarrays, and with the element 10 only, the total number of subarrays can only be 1, which is nothing but end minus start plus 1, right? So these total number of subarrays can be formed with this single element 10, and you can see that end is also 0, start is also 0, so 0 minus 0 plus 1, so there is only one subarray, right? So what I'll do, I will have one variable subarray count, right, which is initially set to 0, and now I will increment it by this count, which is nothing but 1. Okay, great. Now let's move further. Now I will simply take this end pointer and move it forward. Now my end is pointing to 1, and now once again I will take this value, multiply it into my product. So 10 into 5, now it will become 50, and I will check whether my product is greater than equals to k. No, it's not greater than equals to k. That means the total number of elements that you have in your window is now 10 and 5, and hence there will be 2 different subarray which can be formed. One is 5 only and other one is 10 and 5, right? See, the 10 which was previously formed, that is a different subarray, right? Now when we are including 5 to this 10, so there is this subarray which can be formed, and then there is one subarray which can be formed, right? So what we will do, we will basically count total number of subarrays which can be formed with this particular subarray, right? And that can be formed simply end minus start plus 1, right? And if you will solve this, so end is pointing to 1, 1 minus 0 plus 1, which gives you 2, and this 2 is nothing but 1 is 5 alone, and then and other subarray is 10 and 5, right? Great. And we can simply add this particular value to our count, so hence it will become 3. Great. Now let's move forward. So we can simply make our end pointer move forward, right? Now our end is pointing to index number 2. Let's take this value and multiply it with the current product. So current product now will become 100, and now what will happen is so at this point in time your product is greater than equals to 100, right? Which means like we cannot take this particular subarray because this particular subarray is crossing the product which is like greater than or equals to 100, right? So we cannot take this subarray. So what we will do, which means like I cannot form these subarrays when I am including this 2, right? So what we will do, we will start removing the elements from the left side. So what I will do, I will simply take this start value and remove it from my product. So to remove it from my product, because we were multiplying it, right? So we were not adding the values. If we would have been adding the values, we would have been subtracted, right? But right now I'm not really adding, I'm multiplying it. So to remove this 10 from this I will actually have to divide it. So what I will do, I will take this start value and divide it by my current product, and I will make my start move forward, because now this 10 is no more a part of my window, right? So my current product now will become actually 10, right? So my current product will actually become 10 because this 10 is now removed from my sub-array, right? And now once again I will check if my product is still greater than equals to 100, right? So now my product is not greater than equals to 100. That means my product is now stabilized, right? My current sub-array is actually within the constraints. So what I will do, as soon as I am within the constraint, as soon as my current sub-array product is not greater than equals to 100, that means I have got a new sub-array, I have got a new answer, right? So what I will do, when I am including this 2 will make a sub-array, and then this 2 will combined with 5 will make another sub-array, right? So eventually what will happen, I need to count total number of sub-arrays between my current window, right? So I can do it once again, like and minus start plus 1. So 2 minus 1 plus 1, which is 2 once again, right? And I will add this particular answer like to my current sub-array count, right? Great. Now what will happen, now current product is actually stabilized, so you don't need to move your start pointer move forward. What we will do, we will simply take this end and move it forward, right? Now my current element is 6. Let's multiply this 6 into my current product and it will become basically 60. Just check whether if your current product is greater than equals to 100. No, it's not. That means we can actually count another, like we have got another new sub-array or maybe number of different sub-arrays. So let's count them. When I am introducing this 6 into my current sub-array, this 6 alone will make one sub-array whose product is less than actually 100, right? And then this 6 with combined as 2 will make another sub-array, right? And then this 6 combined with 5 and 2 will make another sub-array. So total number of sub-arrays are actually 3. And this value can be simply calculated by end minus start plus 1. And 3 minus 2 plus 1, which is 3 minus 1 is 2 and 2 plus 1 is 3. So this is eventually giving me 3, and you can see these 3 sub-arrays are those. And I can simply add this 3 value to my current sub-array and it will become 8. And because still your product is not crossing the constraint, hence we will simply take our end pointer and will make it move forward. And now your end is pointing out of the bound of the array, right? So eventually we will stop, like our loop will terminate over here, and we can simply return this particular sub-array count, whatever we have right now, right? And this is it. So in this particular approach, we are simply iterating from left to right. You can see that your end pointer was pointing to each of the element only once. And in the worst case scenario, your start pointer can also point the same element, but only once. So in the worst case scenario, each element is pointed by start or end only once, like one time. So eventually the time complexity for this particular problem will be big of n. But we are really not taking any extra space except these few variables. Hence the space complexity will be big of 1, right? And I hope you have understood this problem. So now let's look at the code, right? So what I will do, I will simply take one variable start, one variable sub-array count, and another variable will be product. Let's assign these values. So start will be equals to 0, sub-array count will be equals to 0, product will be 1, right? And now we can simply run a loop for end is equals to 0, and is less than nums.length, and end plus plus. What I'll do, I'll simply first multiply my current element with the current value, which is nums of end, and I will check. First of all, let's do one thing. Let's increment this sub-array count. So sub-array count is nothing but it would be plus equal to end minus start plus 1, right? You know it very well. But before actually making, like as soon as we multiply our current pointer with the product, it is possible that this product is exceeding the value k, right? So before that, we need to check while product is greater than equals to k, we need to make sure that like we are dividing the current product by the nums of start, like whatever start point value is there, like whatever value is to the left and is still the part of the window, that should go out of the window, right? So we will do it and we will simply make start plus plus, right? And this is it. And finally we can come out of the loop and we can return total number of sub-array count. And let's try to run this once. So this should work, but it will fail. Yes, it is failing for one example. You can see that what we have done, we are basically taking this product to be 1, right? And because in this particular array, each of the element will be positive, right? So what will happen eventually, as soon as you are entering into this loop, your end is not getting incremented. You are still at 0 index, but what will happen, 1 is greater than 0. So it will actually divide it by 1 and your start will be incremented once again. So your product is still greater than k. So what will happen, like it will eventually keep incrementing the start pointer. So we can actually have one condition over here. right? That if k is less than 1, we can return 0 because there will be no sub error, right? So let's try to run it once again, and it is accepted. Now let's try to submit this. Okay, this is failing on the, oh sorry, let's keep it equal. Okay, accepted. Let's try to submit this once again, and there we go. So it got submitted, right? So this is it from my side for this video. I hope you have understood this problem statement. So I'll see you in the next video. Till then, bye bye.